Hey everyone, welcome to the community call. This is Jonathan with EthStaker, and we have community call number 56 today. So we're excited to welcome Luca here. Luca's been working on the Vero software and at your company, Serenita, right? And so we wanted to invite him to come talk about this project and what it's doing for Ethereum's defense and resiliency and for the staking community in general. So yeah, we have a number of folks from the EthStaker crew here as well. Hello, Remy, Sam, Hanny, and Buddha. Um, and thanks for all those listening to the community call live. We'll have Q&A as usual, and this will be recorded and saved. So um, we can get into it. Luca, I can let you introduce yourselves, um, so we can talk about your history and how you got into this project, and just any history you have with the EthStaker community as well, because I know you're pretty active in a number of different ways with the broader community. So how does that sound?
Perfect. Yeah. Hi,
Cool.
everyone. My name is Luca. Yeah, like Jonathan said, I've been involved in various different ways in the ETH staking community for a few years now. Like during the bear market of 2018, 2019, I managed to accumulate enough ETH to be able to solo stake, which was very different times back then, very different prices. But yeah, then I started staking as a Genesis staker and did all the test nets, the Medasha test nets, the recoveries, all of that fun stuff back then in 2020, I think. And then I started, well, I saw that I was making some staking income, right? Some ETH. That was nice. But I didn't know how to track it. So that was the th first thing I built in the community. It was a simple Python script that allowed you to track your staking income. I wasn't completely satisfied with it being a Python script, so not everybody knows how to run Python. So I then decided to turn it into a website. It was called eth2.tax back then, but at some point it got moved to ethstaker.tax, which works till this day. Yeah, it may seem like a simple website, but it's a surprising amount of work, especially like during those past network upgrades. Like every network upgrade meant I had to do something new on the website. So like withdrawals were enabled. So that meant different types of accounting for that income. What else? The MEV, like the merge in itself. So you had a consensus layer income and then you added the execution layer income. So yeah, that was EthStaker tax, my dueling beginnings. And then over the years, I just staked for myself for a few years, and then I had the idea of like uh, creating and founding a staking as a service company, which has been around for 2 years now, Serenita. Um, the main reason why I did that is I wasn't that happy with the way the big guys that we all know were doing things. I didn't like the way they were like using Geth as the supermajority client, that sort of thing. So that's how I got started, how I got here. And once I did start a company, I decided that yeah, we want to avoid client bugs, and that's how I started working on Vero. That was almost 2 years ago now. Yeah.
Cool. So you started Vero in 2023. Is that sometime in that time frame, or 22
Yeah.
or something like that? Yeah.
23, yeah, that's when I had the idea and started working on it. And it took quite a while to actually get to a working validator client. But we've been running it in production ourselves for the last year. So yeah, it's
Cool. Um, yeah, this one, I mean, I think we had people in the community aware of Vero and other things like it. I know there's you you know, um, but it's like, especially with emerging risks out there and situations where we see client bugs present, risks of varying degrees. I think there's a lot of interest from people about understanding more about these kinds of options and these ways to like bring this into your setup. Both, and my thinking too is that it's good for operators of any size, right? Like it's a defensive thing as well as a network um, health thing. So I feel like anybody listening to this, whether you're a, individual small staker, or really any kind of setup that you have, it could be, or a professional large scale staker, it could be something that could add to the defensiveness and security of what you've got going on. Because, I mean, I think the thing that especially made me think of it was everything that went on with Haleski in the, what was that, early spring, late winter there, with the network upgrade that we tried to do with the testnet there for Pectra. But you've been doing this well before that, right? So I mean, what was your first, what kind of like triggered the idea for you about like, oh, we need to do this? Because I don't think Pectra was probably not the first bumpy testnet upgrade, I'm guessing. I listened to a few talks you've done, and it sounded like there were some other experiences that were kind of formative for you in coming up with this idea. Is that right?
Yeah, especially if you look at the, I suppose, are you gonna link the references I sent to you in the call notes, right?
Yes,
The
we
okay,
can
so
provide those.
I just did a talk at ECC, which really like shows the history of all the client bugs that we've seen that were able to affect consensus. And there were quite a few, even during the proof of work era, but also a couple in this proof of stake era. And a lot of those happened before I actually started at the company. So there was that's I guess that's what made me think about it. There was the big Gurley incident on the Gurley testnet. It kind of went under the radar because the bug happened as the testnet was already winding down. So nobody really cared that it like went that way, but there was a pretty serious bug there at the end. Um, I think it's just a bit of an under-discussed topic. Like everybody focuses on, okay, let's get the best uptime. Let's be online all the time. But when you think of the risks that are associated with those client bugs, it's different than what we had before during proof of work. Like if you had a client bug during proof of work, you could always like go back to the correct chain. You just like make sure that that chain gets mined on top of. But with proof of stake, it's just completely different. As soon as you actually finalize a block on a proof of stake like chain or one of its forks in a forking scenario, then there's just no going back. And yeah, I think not a lot of people like completely have that understanding of it, or I don't know how to say it.
Yeah. No, I mean, like I guess for me, like the Haleski experience was very illustrative of what the risk is. And you see like a lot of that test net go down. And it's kind of like the most recent experience we have maybe with some kind of scenario like that. So, I mean, maybe you could just describe it a little bit about what Vero is doing then. Like how is it helping with, I mean, sticking with principles of client diversity and decentralization, helping navigate situations where there's a bug. I mean, and don't let me like describe it wrong either, but my understanding is like it's if there's a situation where there's a bug in multiple clients, Vero is set up to be able to help navigate that in a more graceful way, right? A software like this. And
Yeah.
I guess like I'm just curious to like hear it from you, like architecturally, how this is set up and how this can help people and just
Mhm.
what it's doing.
Yeah. So the main benefit of Vero when you compare it to the traditional validator clients that were built by the core devs like Prism, Lighthouse, and so on, the main difference is that Vero is a validator client that can actually talk to multiple different beacon nodes at the same time. So it can talk to like you can set up a Prism beacon node, you can set up a Lodestar one, you can set up a Nimbus one, and if you like connect Vero to those three beacon nodes, it'll fetch the state of the chain from all of them, and it will only attest to the state of the chain if a majority of those beacon nodes agree among themselves. So if you're running like this combination that I just said, Prism, Lodestar, Nimbus, if Nimbus, say, has a bug, Vero continues attesting as long as Lodestar and Prism agrees on the chain. So in this kind of three beacon node scenario, you're completely immune to any single client bug. So if any of those three clients has a bug, you're going to end up on the chain that the other two clients share. So that's a way how that's the way you protect your validators against single client bugs using this kind of three beacon node scenario. You can even go a little lower, so you can also just run like two beacon nodes, and as long as those two agree, then Vero continues the testing. But yeah, if you just run a single beacon node, then Vero doesn't have any benefit because it doesn't have any other reference to check against. And then there's like, so this was the case of protecting against a single client bug, but you can like really scale this up, especially if you're a professional. You can run like all the client combinations, like 5 different CL clients connected to 5 different EL clients. And then you can also customize the threshold, the like consensus threshold that you're comfortable with. And that allows you to like say, I only want to continue a testing if at least 4 clients agree on the state of the chain. So you can be as conservative or as open to risk as you want. You can just define that threshold.
Cool. So like, I mean, one question I have just to jump into some that are top of mind is like how would you actually like what does it look like to actually set this up? Like, do you actually have to be running different copies of um your consensus layer, like a consensus layer client in different places, or like the architecture of like the beacon node and all this? I'm just, you know, how does that fit in? Or if you're running this on your own, like if you're a home node operator or something, does it require additional kind of redundancies to be set up in terms of what you're downloading, what bandwidth you're using? Like, how does it change the architecture from maybe a more classic setup right now once you have this?
Yeah, it depends. If you also look at the ECC talk I did, I showed like the way you can transition from the very simple setup where you only have like a single client combination to a Vero powered setup. So it shows also this kind of architecture. I think one of the things you might run into is um, Vero doesn't load validator keys itself, so it never like has access to validator keys, and it requires those validator keys to be loaded into a remote signer. So that's something that probably most home stakers are not gonna have set up right now. It's a bit more complex than just loading your validator keys into your validator client. But yeah, that's a decision that I made just to make the software more secure by default. So like you can just say Vero never has access to validator keys, so you don't like have to worry that Vero could steal those keys in any fashion. So yeah, that's one thing architecturally. So once you do move those validator keys into a remote signer, that has some other benefits besides being able to use Vero. That also allows you to switch between other validator clients. So architecturally, you're looking at an execution layer client, then a consensus layer client, and then a validator client. And this validator client talks to the remote signer, which contains your keys. And you can choose Vero to be your validator client, but you can also choose Lighthouse, Prism, whatever you want, because they all support this way of setting things up. So they all support talking to a remote signer, so they don't need to necessarily have access to your validator keys. And where that is beneficial is that if any of those validator clients were to have a bug, you can just switch them over and you don't have to like move your slashing protection database around because it's like the remote signer takes care of protecting against slashing. So that's the first thing. Using a remote signer is kind of required for Vero, at least for the moment. And then when it comes to setting up these different beacon nodes, so adding more client combinations, that very much depends on how you have things set up. But for the home stakers, I would probably just recommend like buying a new NUC or a new machine and spinning up a new client combination, seeing if it runs well. And as soon as you're sure that actually it runs well, you can just like point Vero at both of your nodes.
Cool. Yeah, I think it's really like interesting to just see how simple it kind of is. I mean, it adds some complexity, but it's kind of like, okay, if you're used to running a staking setup with an EL and a CL, and it's kind of set up in that kind of classic way that I think a lot of people have, here's how you take it the next step further. I heard in your talk that you were, looking for trying to get to like a 40% penetration, which would be great in the staking ecosystem because it just feels like it would make Ethereum in general much more resilient if something like this did happen to multiple clients at once, um, where it could, you know, stakers could be protected at this extra level. Um, so yeah,
Yeah.
I actually might personally I listened to the talk and I want to go back and watch it because I think there was some visuals that you had in there. And I know you brought some of the visuals, so maybe we can actually get some of that like shared here at some point too with
Yeah,
just
that could also
helping
help
people
with
see
the
that. Um,
architecture.
yeah,
Let me see if I can share my screen here.
because like I, for me, like the way I learned about all this was, using some of the guides where you're doing the execution consensus, like the somewhere ESAT level guides. And it was not too long ago where I was like, oh, you know what? There's actually the validator client involved in here. And just if you look a little bit deeper, there's other parts of the architecture that people can mix and match. And so I think this is taking advantage of that modularity to mix and match these different parts, right? Um, and helping gain some, adding some complexity that improves security. And so, yeah,
Yeah.
yeah, Booty, if you want to jump in and
Oh
ask.
yeah, now you gave me the break.
No,
I'm
I'll keep talking if
curious.
you guys don't interrupt me.
I'm curious how Vero is differs from Vouch, and why would someone use Vero instead of Vouch, or vice versa? If you're
Yeah,
familiar with Vouch.
of course, yeah. So let me just share this architecture and that will also help answer this question, I think. Let me see. So let me just recap really quickly what we were talking about, Jonathan.
Hmm.
So this is like a simple setup where you have a execution layer client, consensus layer client, and the validator client of your choice, like a traditional one. If you want to get started with Vero, like I said, it requires you to move your keys into the remote signer. Once you have that, though, you only need to swap out that validator client for Vero, which is very easy. And then you can just continue running in this simple kind of setup, even with Vero. Like Vero doesn't necessarily require you to run multiple client combinations. You can just run one. And as you get more comfortable, you spin up these different client combinations. Once you're happy with their performance, you know that they're not affecting your network too much or anything like that, then you can hook up Vero to all three of them, and it's gonna start this consensus process among the different client combinations. So going to Buddha's question, how is it different from Vouch? So you can imagine Vouch in the same place that Vero is in this diagram. It works very similarly. So it also is able to talk to different beacon nodes at the same time. The main difference, I think, is that Vouch requires the use of a different remote signer implementation. So Vero and all the traditional validator clients support Web3 signer, whereas Vouch has a completely different signer implementation that they developed themselves as well. It's called Dirk. So that's one of the main differences. Vouch requires you to use Dirk, and Dirk has some advantages, like for the professionals, you can like split up your keys into yeah, let's not get into that for now, but that's the main difference, I think. So if you do go with Vero, the benefit of Vero supporting Web3 Signer is that if Vero has a bug itself, you can just switch to a different validator client and continue going. Whereas if you're using Vouch, you're using Dirk, and you can't switch to any different validator client. You need to wait for a Vouch fix, basically.
Yeah, makes sense.
Got a question myself, if I may here. The consensus algorithm used by Vero, like how complex it is, and like how can we be sure that it will not affect like your proposals or like your rewards, or like if I were a stakers, that would be some of my concerns. So I don't know if you can maybe reassure stakers about using Vero in that sense.
Okay, yeah, sure. So the consensus, it only affects attestation duties because that's the only thing that can actually get you onto the wrong fork. You can like, when it comes to block proposals, you can propose an invalid block and it's no big deal. It doesn't really matter. The important thing is not to attest to the wrong chain. So this whole consensus algorithm, the consensus mechanism that Vero uses, it only concerns the attestations. And what it does is when it is time to attest, it asks all of the beacon nodes to tell it their view of the head of the chain. So if a majority of those beacon nodes agrees on the head of the chain, then actually Vero attests to it. If you're connected to 3 beacon nodes, by default, it requires 2 of them to agree. So a majority, you can customize it, like I said. But yeah, by default, it will require 2 of them to agree. And as soon as the 2 quickest ones agree, it starts attesting. So it doesn't like wait for the slowest 3rd beacon node to report back. It tries to like attest as quickly as it can.
Good to know. Thanks.
And those beacon nodes are going to process the chain state like separately and in parallel, so it shouldn't slow you down too much.
Does it mean that it will most of the time ignore like the slowest beacon node in a sense?
When it comes to attestations, yes. And it also exposes that as a metric, so you can see like which beacon nodes contribute to the attestation consensus mechanisms the most. So you can really like look into it.
So that
Yeah,
like
and the rest of the process, like I said, the other duties are not affected by this kind of overhead at all.
so is it correct to say that the validator client, Vero, when Vero is the validator client, it's like looking at your local copies of Lodestar, Lighthouse, Grandine, whatever, and making that assessment on its own about what's matching up. It's not like taking this from any other place. So it's like I'm just trying to think like, is this keeping things like decentralized in the sense that you're controlling how it's looking at things? And it sounds like there's settings where you can like configure all of this, how you want that logic to work on your own end, right? Is that an accurate way to put it?
Yeah, one of the reasons why I made this threshold configurable for people. So like in case of this 3-node setup, if you're very conservative and you definitely don't even want to like risk attesting to the wrong chain and you want to use all of those clients' outputs, so you want all of them to agree, you can just up the threshold and set it to 3. So that's when you would be waiting for all 3 to agree. But there's also the other another like kind of setup where you would hook Vero up to 2 nodes, which maybe like some home stakers would like to do. They often have like a single fallback node. So in that case, it is a bit impractical to have the default majority threshold because that means both of those nodes have to agree. It has to be more than 50%. With 2 nodes, that means that both of them have to agree. So in that case, you might wanna like lower that consensus threshold to 1, especially if you plan to like perform a client update or something like that. Otherwise, you're gonna go offline while that client is updating because it's not gonna see the same chain as the other one. So yeah, it's very much in your control what you want to do and how you want to set it up.
Would you suggest running it on the same server so there are no issues with the connection, I guess, if they're distributed among the world?
Well, we haven't like in our setups, we don't have them distributed around the world, but we do have the beacon nodes and the client combinations distributed around the whole continent of Europe. So at least for that kind of setup, it works really well. It would definitely be interesting to me to see how it would perform with beacon nodes around the world. That would be very interesting, yeah. If you want to try that out, Buddha.
I'm just curious about the like how this worked out in the Haleski upgrade. Like were there validators nodes on the Husky testnet that were running this, And what was that experience like? Because it seems kind of like a interesting live failure to test something like this out on, right? Yeah, it looks like you've got some stuff about that.
Yeah, Holeshki was very, very extreme because I think it was three, maybe even four. Let me see, I have it here. Three execution layer clients basically uh, went onto the wrong chain and at the same kind of consensus bug. So they forked away at the same exact time. So for us, we were using two of those in a 2 out of 3 setup. So our validators were actually following the wrong chain despite using Vero, just because 2 out of our 3 testnet clients went onto the wrong chain. So yeah, if you have like a bug that affects many clients in the same exact way, then even Vero won't protect you unless you, of course, like configure this consensus threshold and go extra conservative. So during the Holeshki Pectra incident, we were running, like I said, the 3 client combinations, and we had a consensus threshold of 2. So if we had a threshold of 3 out of 3, we would have stopped the testing. So that's what we took away from this incident. So during and around network upgrades, we're gonna like up this threshold to the full amount. And if any of the nodes disagrees, then we'll just stop the testing and see what's going on and wait for an investigation to see which chain is the correct one. And that seems like a good idea because you are going to get a slight reduction in performance. So you may be testing a bit later because you're waiting for all those clients to agree. But during I don't think it's such a bad thing to have slightly worse performance over like a 24, maybe 2-day, 24-hour or 2-day period of time, during which like there is much more, there is a high probability for client bugs to occur. So yeah, that would be the recommendation that I would have for other node operators that are considering Vero. So set up a nice client diverse architecture and then make sure to adjust the threshold around network upgrades to be extra safe.
So does that create a situation where it's sort of like you're weighing whether having low or high participation, like low participation being a problem? And like imagine if like Vero had like, I don't know, just say it was 100% usage across the network and everyone did that, like would that create kind of like a two bad scenarios to consider? But obviously you don't want to have the wrong chain be finalized, and then that would be like maybe the worst scenario than like the network going offline because of, I guess I'm thinking through like which catastrophic scenario is worse, right? I don't know.
Yeah, well, the good thing about the way that Vero does this, it doesn't stop all duties. So it only stops at testing. So if in this hypothetical scenario where everyone on the network would be running Vero and we'd like have a network upgrade and one of the clients would disagree, so the entire network would go offline, would stop at testing. The good thing is that Vero still continues producing blocks. It continues participating in sync duties. So the network wouldn't lose liveness. The blocks would continue to be produced. The only thing is nobody would be attesting to the validity of those blocks, but we would see blocks, we would see transactions, they wouldn't be finalizing. So it's
Okay.
really
And what does that have in terms of like slashing consequences? Like, does that mitigate the consequences of slashing for a large set or like non-proposers basically? Or what is it mitigating there?
it is mitigating it's mitigating that your validators end up on this wrong chain. So they would, yeah, it stops you from attesting to the wrong chain.
Okay.
And if you, yeah, and that then gets back to the situation, like if you attest to the wrong chain and that chain gets finalized, then you're in real trouble and you're basically very much screwed.
Yeah.
Yeah.
Yeah, we've tried to do like various education around these slashing scenarios because like obviously those are like catastrophic scenarios, and maybe I think you might have seen, or people listening might have seen a couple months ago, we did an illustration to try to put all this in context about, okay, you know, slashing is kind of like the worst case catastrophic scenarios, but you're also trying to deal with mitigating those scenarios too. So that's why I asked this, because it's kind of like this definitely takes you a level deeper to understanding nuances in each of those scenarios, and you know what the results are if you do a testing or proposing or this all these different things. So yeah, we may have to do like an expert version of that illustration maybe someday if people are interested. There's a question here I can ask out loud here from Valifar in the YouTube chat about, has Vero gone through a security audit? If so, is that report public? Is that something you guys have done?
We've been asked that before, definitely, and we have not done a security audit. It's possible that we will do one, but for now, I'm leaning towards no. The reason being is that it's just such a simple piece of software. It doesn't have direct access to validator keys, so you don't have to be worried about that, like the worst case that it would somehow exfiltrate those validator keys to some remote location. And another thing that also plays is Vouch, for example, is also this very similar kind of software, and it's also not been audited, but the remote signer, Dirk, has been. So that's, I think, like also Web3 signer, I think it has gone through an audit, and that seems like the more critical part of the whole architecture to focus on. So the piece that's actually signing and interacting with those private keys. Whereas the validator client, Vero, it's yeah, what it can do, what it does is it sends a bunch of HTTP requests to the beacon node. It sends a bunch of requests to the remote signer, but it doesn't do a lot of complicated processing. The only thing that could be considered slightly complicated is this attestation consensus mechanism. And that's just like very well unit tested. And that feels like a more appropriate way to test Vero.
So
Isn't
oh, go ahead, Remy.
sorry, yeah. Isn't
Go ahead.
Vero like still controlling the keys indirectly through this interface with the remote signers? Like it can tell, I guess, sign this block or like sign this proposal and then publish it through the beacon nodes?
Yeah, yeah. It could, in theory, it could, let me think. Yeah, I guess it could, in a worst case scenario, like get an attestation signed that is from the future, and that would prevent you from attesting until that signed attestation, just in order not to surround yourself. So yeah, that's a concern, possible concern. But
so I guess there's still potential value in doing a security audit potentially, in my mind, but like I don't want to be involved into how you manage that project. But to me, it seems like there would be value even if it's quite simple in terms of like even in terms of like managing keys.
yeah, yeah. I'm open to it, but those things are like quite expensive. So unless we get some supporting funding to get it audited, it will be difficult to justify.
And we're fully aware of like the cost of these security audits, having gone through a few of them. And if there's anyone interested in sponsoring this, that would be a great plus for the community.
Yeah, I've got some parties that would be willing to co-sponsor. So if anyone else would like to get involved, then definitely let me know.
I have one last question. I'm interested in your thoughts about the sustainability and maintainability looking into the future of Vero. Because as you said in the beginning, you started working on it 2 years ago, and it took you about 1 year to use it in production. So that means to me that it's not that easy to get started and understand what's going on. So what do you say to those that want to use Vero but are worried because the project is relying on one entity, which is you?
Yeah, it's a difficult one to answer. I also attempted to answer it at ECC. But let me just start with saying the year that it took me to get to like a working validator client, I didn't work on it full time. So it was just like whenever I had some time left over to focus on the more technical side of the business, then I worked on this. A lot of the time also was spent on testing. So you like it, I think like Vero was testing on test nets probably 6 months before we actually started using it in production. So it went through like months and months of testing just to make sure that nothing is off. And when it comes to the long-term sustainability, I can't guarantee you anything like for the next 10 years, but Serenita as a company has enough runway for a few more years. We're not worried about going out of business anytime soon. And we do want to keep on using Vero ourselves. So as long for those next few years at least, we're gonna support it and we're gonna make sure that it works on future network upgrades as well. And
Yeah,
the Python code base is currently less than 4,000 lines of code, which is not much at all. The Fusaka upcoming Fusaka network upgrade, I've already got a PR open with Fusaka support. So Vero started off supporting DNAP. Now it supports Electra. We're gonna support Fusaka for sure. So I think that kind of sets the expectations. We're gonna be ready long before the network upgrades go through on mainnet. Like with Electra, I had a Vero version ready, Electra ready, back at DEF CON. So that was back in November, like 6 months ahead of the network upgrade itself.
Yeah, I was about to say that most of the time it's not a problem to rely on projects like these. It's usually when hard forks happen that are most of the time like once a year. So I think the risk is small, but it's there. And also, who do you think is the target user? Is it more large entities or home stakers? Because I do think that running it at scale for someone with 1 or 2 validators will eat up most of their revenue. So yeah, what do you think?
Yeah, I think that's completely true. And it's similar for DVT stuff as well. Like if you're gonna need to run like 4 or 5 different servers to support one or a handful of validators, it's not gonna make much financial sense. The target audience, therefore, is mainly professionals. For those, I think it makes perfect sense to hook Vero up to a combination of 5 different clients and just use a 3 out of 5 threshold by default. If they are more conservative, go for 4 out of 5. But I think like 3 out of 5 is gonna be more than enough during normal network conditions, and maybe up it to 4 around network upgrades or 5. And yeah, those professionals, especially the really large operations, they can definitely afford to run a couple more machines to get this kind of security.
So that's the main
Yeah.
cost, though, is like having different nodes that you're running concurrently. Is that, and like the resources that go along with that?
Yeah, and you need to
Okay.
do maintenance on all of those. So it does add up a little, but I think for the professionals, when you consider that you're avoiding this huge risk, I think it does make sense
Yeah,
to
and like
invest a little bit into
it
that.
sounds like we already know that some of the professional setups have like whatever, they'll like do like 33% of their stuff and one client combination, 33% another. I'm just like throwing out numbers, but like they already do some level of this splitting up to create variety there for security, like safety reasons, and probably network health reasons too. So this is just kind of like doing that in a different way that adds some, if I'm understanding that right. Is that
Yeah, I mentioned that approach in my presentation as well. So it's what I call the simple approach. You just like split up your validators among the different combinations, and it would be enough. And it's great if you do this. Um, if everybody did this, then we wouldn't need Vero because we just like have smaller client shares across the network. But unfortunately, if you want to go this way, you kind of rely on the rest of the network to do something like that too. Otherwise, you're not completely protected. So yeah, I'm happy to push this kind of setup as well. I think as a community, the EthStaking community has tried to push for client diversity. I think we've like tried pushing these larger entities towards these kinds of client diverse setups, but we're now like 5 years into the process and we're still not anywhere near where we would actually like it to be with each client around 20%. So I'm skeptical that we're actually gonna get to that ideal point. And therefore, I think the 40% goal that we mentioned earlier is a bit more achievable, and it still gets us to this same safe situation for Ethereum where the wrong chain wouldn't finalize. And I'm not pushing for 40% of the network to run Vero. I'm pushing for 40% of the network to run any kind of client bug resistant setup. So that can be Vero, but it can also be Vouch. It can be DVT in certain cases. So yeah.
How does this you mentioned DVT, like how does this relate to what that can do? I mean, is that how, I guess DVT is having different participants within that setup. So this is just like splitting out at a different level, right?
Yeah, with
Yeah.
DVT, it's a little bit different, especially since we recently found out that SSV doesn't protect against all client bugs. And I don't know if we have news on the OBOL side. So right now, SSV doesn't protect against these dangerous kinds of client bugs, but they're aware at this point, and they're hopefully gonna fix that. But in theory, DVT would be able to protect against client bugs in a similar way. So if you would be running like this kind of 4-node cluster, and if one or two of them go on a different chain, your validator would not attest to the wrong chain. So it's a little less configurable because you're kind of stuck with either 4-node setups or 7-node setups with DVT. So you can't just like say, I'm okay if 2 of the clients agree, or I'm okay if I want to require 6 out of 7 to agree. That's not possible with DVT, but it still can get you pretty far.
Okay. So I guess the audience then for something like Vero is larger professional operators that would want to have this
Yeah, I think
logic.
so.
Yeah.
Because with the goal of 40%, it's like if we get to over 33%, we're already good. The 40% is just kind of a buffer above those 33. And getting to 40%, where's the slide? Here it is. Getting to 40%, I don't think it's that difficult if we manage to get really large entities on board. Because like 40% of the network stake is probably run by maybe like 30 different entities, which is not that many. And yeah, it would require those entities to invest a little, but it would have a huge impact on the network security. And we could just like seriously stop worrying about finalizing a wrong chain ever again. That would be nice.
That would be great. Yeah, less concerns about catastrophic events. Sounds like a great thing.
Yeah.
I mean, can I go back to the question about the testnet upgrades that happened? Because you talked about Haleski, but I think Sepolia also, had some things happen during it that weren't as catastrophic, but maybe you can talk about, it sounds like you guys were running Vero on that as well. Like what was that experience like?
Vero actually doesn't support Sepolia at the moment, so we
Oh,
weren't
okay.
running a Vero
Okay.
node, but I know a little bit about it. So yeah, we're not running any Sepolia nodes ourselves either, but it was a similar kind of client bug. I see here on my slide it affected all of the EL clients. I'm not sure if like all of them actually had this issue, but at least the vast majority of them had the issue where they basically weren't expecting um, the different type of deposit events that happen on Sepolio, because it has a permission validator set. So whenever you deposit to the deposit contract there, it emits a different kind of event than all of the other networks. And the EL clients just weren't prepared for that. So they started like, yeah, they didn't like that. So that needed to be fixed. And then I think there was even some kind of attacker that was trying some things, destabilizing the network, and that then required like the node operators on Sepolia to coordinate a little bit on updating. So yeah, that was messy as well.
Somebody's always trying to make it interesting. I guess I like looking at, I mean, we always want the testnets to go smoothly. I think everyone feels better that way after they've gone smoothly, but it's kind of interesting to dissect them too as like a crash test or something example. And I know that, the dev teams and the protocol teams are working on trying to do scenarios during shadow forks and things like that to create like these scenarios to test them out. But I guess it's interesting to see what happens when they happen on a public testnet too.
Yeah.
Okay.
Maybe one more thing that may be interesting to the folks that we were discussing with in the EthStaker Discord channel. There's a finality risk. We've been discussing these things, client bugs, a lot there. Also talked about the way SSV is gonna approach their fix of protecting validators against client bugs. So yeah, currently what Vero does is, like I said, it talks to all of the beacon nodes and it asks them what their view of the chain is, and it does this every slot. So we were also, Thorsten came to me with the idea, but it's been floated around before, that you don't actually need to come to consensus on the head of the chain every slot, as long as you make sure that you come to consensus on those checkpoints that eventually finalize. So you only need to really come to consensus every 32 slots. So that would also make this whole thing a little more efficient. So that's what I'm gonna be working on the coming weeks. This kind of consensus mechanism V2.
Cool. So we'll be seeing new versions of Vero and more nuanced handling of it. That's cool to see.
Yeah.
Where can people, I mean, is it just following on the GitHub about updates there where people can follow that? I guess or you have your own presence on social media too. You'll probably share these things.
Yeah, we shared, it's probably best to follow the GitHub releases, but you can also follow our Twitter account. We post every time there is a new release. We have a Telegram channel, which we post the new releases into. So there's a couple options there. And we're probably gonna have a Discord server as well at some point, testing things out now. So you could follow the announcement channel there as
Cool.
usual. Yeah.
Yeah, it's exciting to see it develop, and I know we all feel gratitude for you building something like this. It's like one of the cool things about the Ethereum ecosystem is that people are always out there looking for like, how do we create more defensive technology that, gives people more control over how these operations are set up. So, and it benefits the whole network. If we didn't have to worry about that kind of scenario happening, I think that's a massive advancement there. So, yeah, thank you for that.
Yeah, happy to build on these things. Yeah, maybe one more thing I'd like to invite people to do, if they're interested in Vero, is retroactively participate in a workshop I did last month. So it's still possible to just like watch the recording. You can follow the workshop. It's all still available. All the infrastructure that was needed during the workshop is still online. So you can very simply, in like a matter of probably 20, 30 minutes, try out Vero yourself, see what it does, what it works like. So yeah.
Yeah, this is a YouTube video. We'll link to this. I have a note here to add all of these. There's a number of good reference links that we have about this, including the one you just mentioned there from DAppCon, that we can post on the YouTube follow-up notes there, so that it's there for everybody listening
Perfect.
and
Yeah.
the recorded version.
And if you do participate in it, let me know and I can send you a POAP. So that's always nice, right?
Ooh, okay, that's a great segue, actually. So people, I mean, I know we always love the POAPs, and we have a POAP as well for this call, so maybe we can talk about that for a second, Remy.
Yeah, it's on.
It's shown. All right. So everyone hopefully knows the drill about these, but this is how you can go collect it for this community call number 56. So go ahead and send 0.001 ETH to that address, poap.ethstaker.eth, and do it over the next couple days. And you can get the POAP here. It's got the Vero logo on it. It's minted on Arbitrum, so we thank Arbitrum for sponsoring that, powering that POAP mint, and yeah, all the details are there. The fee, or the 0.001 ETH, can be sent on Arbitrum. It also works on Base, Optimism, and Mainnet. So just any option there. And go collect. See who's first. Maybe Sam's first. I think Sam's usually first because um, cool. I think that might be it then. Is there anything else? Oh, someone can still be first. I'm sure it's already happened. Cool. Yeah, thanks, Luca, for coming. This has been really interesting and really timely, I think, too, with just where the protocol is in its development. And it's great to see something like this come online. So thanks again.
Thanks for having me. Yeah, I think there was just a little, like, there's tons of validator clients, there's Vouch, there's DVT, but I think there's a space for Vero as well, where it's like a bit simpler than setting up Vouch or DVT, but you still get the benefits of protecting against client bugs. Some people are gonna go with the other options, and some people are gonna like Vero, so I'm happy either way. Yeah, if anyone of the larger node operators wants to test it, also let me know. Happy to help you out there.
Great. Okay. Yeah, it's a good call to action, and I'll be interested to watch that number track towards 40. I'm, anything we can do to help shed light on this and help that goal happen for the network would be great.
Yeah, it would be nice to get a little more transparency into the setups that the different large node operators use, because even if we do somehow end up with larger node operators using Vouch, Vero, and so on, if we don't see how many validators are powered by those softwares, then it doesn't help as much as if we actually knew that, okay, this much is safe. Yeah, hoping to see more of that.
Cool. All right. Well, yeah, if there's nothing else, thanks again. I'll just note that we actually have another community call coming up next week. So I know sometimes we do these on a unpredictable schedule, but we have one next week about validator gas limits, which will be interesting to discuss. So yeah, join us for that. And if you have any ideas out there for other call topics, we're all ears. We can get different things in the schedule that are interesting to the community. So we yeah, just reach out in the Discord or one of us and we can chat. Cool. All right. Well, thanks.
Thank
See
you.
you next time. All right. Bye-bye.
Bye.